Welcome to video 3 covering the economics of the production possibilities model. Students who have not yet watched videos 1 and 2 should watch these videos prior to reviewing this video. Remember the 4 economic lessons of the production possibilities model. The model demonstrates graphically and numerically a nation's limitations of production for a specific period of time under consideration. The production possibilities model, again, quantitatively and graphically helps economists express the idea of choices, trade-offs, and costs. The production possibility model examines the 3 types of efficiency: full employment, productive efficiency, and allocative efficiency. And then the production possibilities model examines the possibility of economic growth moving forward. Students should be certain to remember these 3 types of economic efficiency: full employment, putting to use all of your available resources; productive efficiency, producing in the most cost-effective method, that is to say, using the least number of resources necessary to produce a good or service. And then the 3rd type of efficiency, which we will discuss in more detail in this video, allocative efficiency, and we will also examine the possibility of economic implications of choosing a point as allocatively efficient. Remember, all production possibility frontiers are built on 4 assumptions. Every production possibility curve built on the same 4 assumptions. The first one is that anywhere along the curve, we can assume society is putting to use all of its available resources, aka full employment. Anywhere along the production possibility frontier, we can also assume that the least cost method of production is being used to produce goods and services, productive efficiency. So anywhere along the curve, society is achieving both full employment and productive efficiency. In other words, to reach potential maximum level of output, we use all available resources and produce in the most cost-effective, using the most cost-effective method of production. For the time being, resources are fixed in both quantity and quality, and for the time being, technology is also fixed. We will discuss how relaxing one or both of these assumptions could create economic growth moving forward later in the video. Finally, we talk about the trade-off between 2 products. This particular video will examine more of a macroeconomic example. The 2 products can be broadly defined, and these will be capital goods and consumer goods. Now, a macroeconomic application of the production possibilities model. Welcome to the pizzas robots world. In this example, pizzas represent consumer goods. Consumer goods satisfy economic wants directly and immediately. Robots represent capital goods. Capital goods satisfy economic wants indirectly and over time. In theory, there are an infinite number of points on a production possibility frontier. However, we only need to draw 5 points to emphasize the economic lessons associated with the model. Let's evaluate what's going on at point A as an apple and E as in everyone. Think to yourself as far as allocation of resources. At A, what's going on with land, capital, labor, and entrepreneur skills in this country? All economic resources are dedicated towards capital good production, robots. No economic resources are currently allocated towards pizza production, consumer goods. At E, the opposite is true. All land, capital, labor, and skills of entrepreneurs are producing pizzas, consumer goods. At the same time, there will be 0 production of robots because no resources are allocated towards this type of production. In the real world, society needs some consumer goods and some capital goods. Therefore, neither point A nor point E would be what economists refer to as allocatively efficient. Neither A, 0 pizzas and 10 robots, or E, 4 pizzas and 0 robots would be the mix of output that maximizes society's utility or happiness. Now we must visit an important economic idea called the law of increasing opportunity cost. In the previous video, we discussed the SARA study world and the Canadian example of the trade-off between producing wheat and corn. In both examples, the production possibility frontier graphed as a linear curve, a straight line. When we graph this data on the next slide, we will notice that this production possibility curve has concavity to it. This production possibility frontier is curved. As soon as a student witnesses or visualizes a production possibility frontier that has concavity, that's curved, you should immediately identify what is present, and that is what economists refer to as increasing opportunity costs along the curve. Now, what does this mean? Each additional marginal choice will cost more in terms of lost production of the other product, the opportunity cost of the other product. Let's talk about this in number terms as we move from A as an apple towards E as in everyone. At A, there's no consumer good production, all robot production. However, society wants some level of pizza output. They want some consumer goods. Therefore, some resources are reallocated away from producing capital goods into producing consumer goods. As we move from point A to point B, pizza production increases by 1, but there's a cost. Industrial robot production fell by 1. Remember, limitations, choices, trade-offs, and costs. It's impossible for a nation to increase output of both types of production simultaneously. Increasing consumer good production is only possible by decreasing robot production. So the first unit of consumer goods costs society 1 unit of capital good production. The first pizza costs society 1 robot. But notice what happens if we move from B to C. Remember, economic thinking is marginal thinking at the margin. The status quo was B as in boy, but now we want to move to C as in cookie. So fewer resources dedicated towards robot production, more resources producing consumer production. Pizza production increases from 1 to 2. Industrial robot production falls from 9 to 7. Notice the second level of pizza output cost more than the first level of pizza production. In other words, the opportunity cost of the second pizza was 2, while the opportunity cost of the first pizza was only 1. Notice if we move from C as in cookie to D as in dog, the third pizza costs society 3 robots. The third unit of consumer good production costs society 3 units of capital good production. And that fourth pizza cost a whopping 4 robots. Now, it doesn't matter if we start as A as an apple and move towards E as an elephant, or we move from E as an elephant back to A as an apple. The law of increasing opportunity costs will be present. In other words, it doesn't matter if we trade capital goods for consumer goods or vice versa. The reason why, or the economic rationale behind the law of increasing opportunity costs, is that these are 2 vastly different types of production. Therefore, economic resources are not readily adaptable, shiftable, or changeable in the short run between these 2 types of production. If we start at A and move towards B, some machines, some factories, some plants might easily be converted into consumer good production, and some laborers might pick up quickly how to produce pizzas, consumer good outputs. However, as we continue our allocation away from industrial robots into pizzas, we're going to need to retrain, reschool, and retool economic resources in a different fashion. In a macroeconomic sense, production of these 2 types of output is vastly different. Therefore, the law of increasing opportunity cost is inescapable. Before we move further, let's make sure students understand how to calculate the opportunity cost of robots in terms of pizzas. In the previous video, we introduced a little trick to calculate opportunity cost. Whatever you are getting, put that on the denominator, bottom of your fraction. Whatever you're giving up, put that on the numerator, top of your fraction, and you will always calculate opportunity cost of one product in terms of foregone production of the other product correctly. Let's demonstrate this. Let's assume we are at point E as an elephant. currently producing no industrial robots, no capital goods, all consumer goods for pizzas. Now society wants some increase in robot production, an increase in capital good output. The only possible way to increase robot production is to decrease pizza production. As we make a choice, a marginal choice from E to D, we shift resources away from pizzas into robots. Society increases robot production by 4, decrease in pizza production by 1, therefore 1 over 4, each robot costs 1/4 of a pizza. Now remember, economic thinking is marginal thinking. Assume society now wants more units of robot production, more capital goods. Right, as we move from D as in dog to C as in cat, robot production increases by 3. Pizza production again fell by 1. 1 over 3. Each robot costs 1/3 of a pizza. Each capital good costs 1/3 of a consumer good. Notice the law of increasing opportunity cost is demonstrated again. Right? From E to D, right, each robot costs 1/4 of a pizza. From D as in dog to C as in cat, each robot costs 1/3 of a pizza. From C as in cat to B as in boy, each robot costs 1/2 of a pizza. And then that last robot costs a whole pizza, increasing opportunity cost along the curve. We demonstrated this important economic concept, the law of increasing opportunity cost, on the previous slide. Let's reiterate its importance and discuss how we observe it, law of increasing opportunity cost. Any production possibility frontier which is not linear, which has concavity to it, which is bowed from the origin, will be demonstrating increasing opportunity cost. Again, the economic rationale behind increasing opportunity cost is that the economic resources are not readily adaptable or shiftable to other uses, because capital good production and consumer good production are vastly different types of economic outputs. Taking the data from our previous slides, point A, B, C, D, and E, and graphing them allows us to construct our production possibility curve. Remember, the production possibility curve represents the best society can do for the time being. The black production possibility frontier represents potential economic outputs for this year, assuming society puts to use all of its available resources and produces in the most cost-effective method, full employment and productive efficiency. So anywhere along this black curve, society is achieving full employment and productive efficiency, using all of its available resources and producing goods and services using the least cost method of production. Remember, the production possibility frontier represents the best we can do for now, because for now we have fixed resources both in quality and quantity and fixed technology, right? And again, this production possibility curve representing a nation's output is demonstrating the potential output of consumer goods on the horizontal axis and capital goods on the vertical axis, and therefore the choices, trade-offs, and costs involved with these types of production. Anywhere along the curve is attainable and efficient. Therefore, any point inside the curve, marked by the highlighted yellow, is what economists refer to as attainable but inefficient. What's taking place at any point inside the curve? Failure of society to achieve full employment of economic resources, not putting to work all available land, capital, labor, or entrepreneurial skills. We will discuss this in more detail in the next slide. A point outside the curve represents desirable but unattainable. Remember, fixed resources in quantity and quality and fixed technology mean, for the time being, a nation cannot escape the limitations of its domestic production possibility frontier. We will discuss the possibility of economic growth moving forward by relaxing the assumption about fixed resources or the discovery of better technological approaches to production. So any point outside the curve for the time being represents desirable but unattainable. So let's talk more about a point inside the curve. U. We label one point inside the curve. So what's going on at U? Well, in a macroeconomic sense, the economy is suffering what's called as a recession, an economic downturn. What happens during an economic downturn? The unemployment rate in the United States increases above what we would say is an acceptable rate of unemployment, right? There are machines, equipment, tools, factories. There's capacity underutilization because the demand for goods and services has faltered. So during an economic downturn, society is operating inside of its production possibility frontier because it's not putting to use all of its available resources. This is costly to society. We're saying we should have more consumer goods or more capital goods or more of both types of production, right? In essence, we're saying if we were operating on the curve, we could increase the production of both consumer goods or capital goods, or at least one of them. So any point inside the curve is attainable but inefficient because underemployment of society's limited or scarce resources. If we're not putting to work all of our available land, capital, labor, and entrepreneurial skills, we're not operating on the curve, therefore we're not achieving full employment, therefore society is suffering foregone economic outputs. The production possibility model represents the best society can do for the time being in regards to economic output given limited resources in quantity and quality and fixed technology. Any point along the curve represents a combination of economic production which maximizes society's use of its limited or scarce resources. Any point along the curve, society is achieving full employment. Any point inside the curve is attainable but inefficient. Any point outside the curve, desirable but unattainable. Now let's revisit the idea of allocative efficiency. We know that a society can produce at any point along its curve. Theoretically, a society could choose any combination of output to maximize utility, maximize the happiness of the citizens who live inside that country. In reality, however, only one point represents the mix of outputs, the combination of capital goods and consumer goods, which is allocatively efficient. We already discussed the idea that neither A as an apple or E as an elephant could be allocatively efficient because society is going to need/want some pizza production and some industrial robot production. Society needs some consumer goods and they also need some capital goods. Therefore, neither A nor E is allocatively efficient. A nation could consume at any point along its production possibility frontier. Remember, the frontier represents the best society can do with its limited or scarce resources and its fixed technology, but assuming we're putting to use all of our available resources for employment and we're producing the most cost-effective method, productive efficiency, the nation will produce somewhere along its production possibility curve. However, only one point on the curve represents what economists refer to as allocatively efficient, the mix of output which maximizes society's happiness, the combination of capital goods and consumer goods which maximizes utility for this nation. We already discussed points A as an apple and point E as an elephant as not allocatively efficient. At point A, society is only producing capital goods, robots. At point E, society is only producing consumer goods, pizzas. Society is going to need some combination of these two different types of production to maximize its utility, some mix of output which maximizes happiness. Now, theoretically, there are an infinite number of points on this curve, but we only have 3 other points on the curve labeled to evaluate B, C, and D. For simplicity, these are plenty of points for our economic analysis. So, which combination of outputs, B, C, or D, which combination of capital goods and consumer goods maximizes society's happiness, satisfaction, or utility? Without any other information, we would probably be tempted to choose D. At point D, it looks as if society is allocating 50% of its resources towards capital good production and the other half of its resources towards consumer good production, which in theory could be a point which maximizes the happiness satisfaction for this society, the mix of output which maximizes society's utility. However, without any further information, we would literally just be making a educated economic guesstimation based on our perception of this economy. On the previous slide, we identified point D as in dog as potentially a point which would represent allocatively efficient for this society. The mix of capital goods and consumer goods which maximizes utility. The mix of output which brings the greatest happiness to the citizens of this country. In the real world, society determines allocatively efficient by weighing the marginal benefits associated with consuming a product versus the marginal cost of how resources that are necessary to produce that output could have been used otherwise. The numbers in this example provide a quantitative analysis of how society ultimately determines which point on its production possibility frontier is allocatively efficient. As with any new graph, make certain that you identify what's being measured on both the horizontal and vertical axis. On the horizontal axis, we're measuring output of consumer goods, pizzas. On the vertical axis, we're measuring, in dollar terms, the marginal benefits and marginal cost of pizza production. So, first, marginal benefits. The marginal benefit is how much additional utility society receives from the next unit of consuming that particular type of output, in this case pizzas. So notice that marginal benefits start extremely high and then dwindle over time. That is to say, each successive unit of consumption yields less utility or happiness than the previous unit. Why is that the case? Well, this is a normal phenomena with human beings. As we consume more of a good or service, it typically provides less and less happiness or gratification. That idea is called the law of diminishing marginal utility. In this graph, the first unit of pizza consumption yields $15 worth of marginal benefits. The second unit of pizza consumption yields less, only $10 worth of marginal benefit, and the third unit of pizza consumption only provides $5 worth of marginal benefits. Again, diminishing marginal utility. As society consumes more of this product, it yields less and less happiness. Marginal cost curve. As opposed to the downward sloping marginal benefits curve, the marginal cost curve is upward sloping. At the beginning of our decision-making process, there are lots of resources to be had. Therefore, resources are not as scarce as they become over time as we begin to produce outputs. Therefore, the marginal cost of producing the first unit of consumer goods, pizzas, is relatively low because there's lots of land, capital, and labor around. But notice that marginal cost increase over time. As we allocate more resources to the production of pizzas, there are less resources available for the production of robots. As we produce more consumer goods, there are less resources available to produce capital goods. Therefore, marginal cost increase as output increases. Notice that the marginal cost of the second unit of production is 10, and the third unit of pizza production has a $15 marginal cost associated with it. Therefore, we can now determine what level of pizza production and consumption maximizes society's happiness. Well, if society were only producing one pizza, what's happening in terms of our marginal cost, marginal benefits analysis? Notice that the marginal benefit of that first level of pizza is quite high. The marginal cost is quite low. The signal to society would be allocate more land, capital, and labor towards pizza production. If, on the other hand, society was producing 3 pizzas, we notice that marginal cost at that level of output exceeds marginal benefit. The marginal cost of 3 pizzas is 15. The marginal benefit is only 5. We would never want a situation where we are over allocating resources towards the production of a certain type of output where the cost outweigh the benefits. As you would rightfully assume, this society is happiest producing 2 units of pizzas. At that level of output, the marginal benefit of consuming the next pizza exactly equals the marginal cost of how resources could have been used otherwise. Let's revisit our production possibilities frontier and finish up this third video on the production possibilities model with a final observation. In the previous analysis, we measured marginal benefits and marginal cost of pizza production, and we identified point C, 2 units of pizza production is where society was happiest. In other words, that's where the marginal benefits, the additional utility society receives from consuming this good, equals the marginal cost of how resources could have been allocated otherwise. One question might arise. We only performed marginal benefit, marginal cost analysis for consumer goods, for pizzas. How do we know, therefore, that we produce 7 robots at point C? Well, remember the entire rationale behind the production possibility frontier. Anywhere along the curve, society will be achieving full employment, putting to use all of its available resources. If this nation uses the exact amount of land, capital, labor, and entrepreneurial skill necessary to produce 2 pizzas, 2 consumer goods, the remainder of the economic resources will be put to use in economic output of industrial robots, capital goods, and there will be just enough resource available to produce, you guessed it, 7 robots. So point C, as in cookie, is allocatively efficient for this nation. This concludes the third video. See you in video 4 of the economics of the production possibilities model.